Good morning students, this is Premchand, IT faculty, Vikas Global Institutions, Jangareddy. Today we will discuss what are the topics that are covered in chemistry, and I will give the introduction to each and every chapter. So what are the topics that are there in the chemistry, right? So before going to see all the topics and all the things in this chapter, in this year, we will first learn what is chemistry, right, which is very important. We will see what is chemistry. What is chemistry? First of all, it is a branch of science. Right, it is a branch of science because in earlier days, in earlier classes and all, we were having only science subject. Later on, in 9th and 10th classes, it is divided into physics, chemistry, biology and all. Even in the earlier times, there used to be only science. Then the segregation became like physical sciences, chemistry and all the things were divided. Even maths, social science, everything is included in science. Okay. So, basically it is a branch of science. Right. So, which is related to this branch of science is related to matter, right? You know the what is the meaning of matter, right? So we already learned in previous classes what is matter, what does it consist of and all. So it is related to matter, right? So it is related to matter, which explains the properties and reactions, right? And reactions, right? So, which explains the properties and reactions of the matter, right? So, what are the properties of a matter? Like, okay, take some chair and a living organism, maybe a human being, right? Both are matter, but they are different, two different, they are having different properties, right? So it explains the properties and also the reactions. We are having many reactions that are undergoing, like biological reactions that are undergoing in our body, but a table or a chair which doesn't have any reactions going on, but it is a product of many reactions, right? So we try to understand in chemistry that of a matter which explains, right? We understand the properties and also the reactions involved in the matter. So this is about the chemistry. So in this year, in the first year of chemistry, so we will be learning a few topics which are already you learned in 9th and 10th classes, and we will continue to learn a bit more advanced stage. So in this year, so we will see what are the topics covered here. Right. So basically this chemistry part is divided into three parts. Right. The first one is physical chemistry. The second one is inorganic chemistry, and the third one is organic chemistry. Right. So in the physical chemistry part, what all the chapters covered, inorganic part, what are the topics covered, organic part, what are the topics covered, we will see in a bit more detail, and I will give the introduction little bit introduction about every chapter, what will be covered in the chapter. So yeah, we will take up first physical chemistry part. right. So in the physical chemistry part, the first chapter is atomic structure. You already learned in 9th and 10th classes, right, about structure of an atom or atomic structure, like the same content but in different classes with different names and all. You have seen few things regarding this atomic structure, but here we will learn a bit more, little bit more we will be learning. So what will be covered here, like what you learned in 9th and 10th classes is what is an atom, and we also saw the theories behind the atom, or the how these atoms are proposed and all. We have seen some theories, like in 9th class I think you have seen Dalton's theory, J.J. Thomson atomic model, Rutherford model of an atom. These things we have covered, we have seen. And even in 10th class, what you have learned is, addition to the above theories, you also learned about the Bohr atomic model, and also quantum atomic model also you have seen, right. So here also we learn about these theories, but in a different angle, in the sense. So all the theories are you just learned in 9th and 10th classes, but here, coming to here, how the scientists were able to do the experiments and then observe these theories, how they concluded to these theories. You will be observing the experiments, and then you will come back to the theories proposed, right. So a bit more you will be learning again up to quantum atomic model you will be learning. At the same time, Bohr atomic model, Bohr-Sommerfeld atomic model, all these things you will be learning in this chapter, atomic structure. Though, so the second chapter will be classification of elements. Classification of elements and periodicity in properties. Right. So classification, what do you mean by classification? Classification is nothing. See, like segregation or the separation. Separation based on a similar quality or similar quantity, right. So for example, if I give you 10 different colors of balls, and I ask you to separate them or segregate them, what do? You take same color of, like, let us say you have 5 green balls, keep it aside. Then 2 blue balls, keep it aside. 3 red balls, you keep it aside, right. So in the similar fashion, you are classifying the elements. Whatever the elements are there, you will be classifying them. Then you will also see the nomenclature. How do you name the elements above 100 number, right. Then you will also see the periodicity. What do you mean by periodicity? Right. So periodicity means which has a periodic nature, which means what? What do you mean by that? So periodic nature means you will have at regular intervals. For example, I have a dot here, I have a dot here. This is at this much distance, right. At the same distance I have to keep it here. That is a regular interval. I think you have learned something called progressions in 10th class mathematics, right. The similar thing you will have, that means regular intervals, right. Regular intervals. So we'll see some properties of the elements which are having a periodic nature. Right. In this chapter, we will be discussing all these things in the second chapter, classification of elements and periodicity in properties. Right. The third one, chemical bonding. Right. Chemical bonding. I think you have learned little bit. You have some idea regarding the chemical bonding in the from the previous classes. Again, here we will learn a bit more, like again you will be starting with least dot structures. Again you will be going to the bonding, different types of bonding like ionic bonding, covalent bonding, coordinate covalent bond, then VSEPR theory, valence shell electron repulsion theory, and then again valency bond theory, hybridization and its applications. And also you will be learning something called molecular orbital theory. You will reach up to molecular orbital theory, which is called MOT, molecular orbital theory. So which is almost approximate to as of now to the existing theories. So it is almost reaches to the realistic system of an atom. So we will reach up to this point, molecular orbital theory, right? Chemical bonding, this is covered in the chemical bonding. So what is covered in the fourth chapter? Fourth chapter will cover states of matter, gases and liquids. Right, states of matter. We already know matter exists in three forms, right? We learned from the previous classes that solids, liquid, gases. So in particular we learn about gases and liquids, right? So you already learned some gas laws as well, Boyle's law, Charles' law, Avogadro's law and all. So we'll be learning again in depth, a bit more advanced. So we'll be learning all these things, and also we'll look at the ideal gas equation. Also we'll see Graham's law and all will be covering in the states of matter, right? So the next part is stoichiometry. What do you mean by stoichiometry? A bit different word, new word for you? Okay, fine, I'll explain you. Don't worry. So you know this metry word you already learned. So trigonometry, geometry, all metries you learned, right? So this is metry means what? Metric means measure, right? So what do you measure in stoichiometry? What do you mean? What do you measure in stoichiometry? So in stoichiometry, what do we measure is, so in chemistry, most of the times, mostly we'll be doing the reactions, right? So reactant to product, product to reactant, like that we'll be doing all these things. So stoichiometry is the quantification of reactants and products, right? So like how much we are taking, how much we are getting, or how much is lost, all those things we will be learning here, stoichiometry. So in this part we will be learning called I think you are familiar with mole concept and all, many of you. So mole concept will be covering here, and again we will be doing a balancing of reactions. I think from 10th class, yes, right. So balancing of reactions, it is there in 10th as well, right? So again we will be doing here. At the same time we will also look at oxidation and reduction reactions, and oxidation number also we will be looking at here. This is the stoichiometry part, right? So this is the fifth chapter for us. So what is sixth one is thermodynamics. Right. So okay, we'll explain, we'll see what it is thermodynamics. Thermo means what? Right, it is related to heat, right? So heat is a form of energy. So thermodynamics mainly deals with the how heat energy is related to different other forms of energy. There are other forms of energy as well. So it deals with the other forms of energy, how it is related. Like how it is related to internal energy, how it is related to entropy, how it is related to Gibbs free energy. All these things will be learning in thermodynamics. Also we will be looking at in thermodynamics we'll see the laws, zeroth law, first law, second law, third law of thermodynamics, right? This is about the thermodynamics part. So coming to the last part of physical chemistry, that is chemical equilibria or chemical equilibrium and acids bases. Right. So you already you have a bit of idea regarding acids and bases, right? In 10th class you I think you had, right? You had. So acids and bases. So you'll how do you define an acid? How do you define a base? How do you do few reactions like acid base reactions? You already did in 10th. So we'll see what are the theories related to acids and bases, like Arrhenius acid, Bronsted acid, Lewis acid, all these acid bases we'll be looking at here. Then we'll also see chemical equilibrium, right? So we'll mostly cover this part, like if there is a reaction going on from A to B, how does the reaction go, whether it is goes or not, so at what equilibrium it is staying, right? So we'll be looking at that. At the same time we'll also see Le-Chatelet's principle here. So Le-Chatelet principle, solubility product, Kp, Kc values of the reaction we'll be looking at in this part. So chemical equilibrium, acids and bases. So in the physical chemistry part, what are we covering? Atomic structure, classification of elements and periodicity in properties, chemical bonding, states of matter, gases and liquids, stoichiometry, thermodynamics, chemical equilibrium, acids and bases. Right. So I think you had a bit of introduction, like what will be there in physical chemistry. So now we will move on to inorganic part. Right. So in inorganic chemistry part, what is covered is, what is the first element? Right, hydrogen, right? Very good. So we'll start with that, right? So hydrogen and its compounds. Right. So that is the first element. So we are it is given much importance even in our textbook as well. So we learn about, we have a special dedicated chapter for the hydrogen and its compounds. So we'll basically what we'll be looking at is, we'll see the position of hydrogen in the periodic table. We'll also see the preparation or the synthesis of hydrogen in different reactions. How do you synthesize the hydrogen? So and its compounds, right? Hydrogen and its compounds. So especially H2O to hydrogen peroxide. We'll look at all these things, and also we'll see its isotopes, right? So isotopes and its compounds like heavy water. We'll be looking at yeah, these things, all these things will be covered in this chapter, hydrogen and its compounds, right? So the next lesson will be S block elements. Right. So in the S block elements, what we'll be covering is, we'll have two parts again. In the S block elements, we are having group 1 elements and group 2 elements. So what we'll be covering in group 1 elements? So it's right. So group 1 element is the left side last group. You can see the periodic table. It starts with lithium, it goes to sodium, potassium and so on. So we'll be taking up this group, especially we'll study its properties, like how does the atomic properties change, how does the different kinds of properties changes in all these elements in the first group. At the same time, how does lithium get separated from the group? It is in the group, but at the same time it has something specialty, because I'm the first one, right? So it is having something specialty. So how does the anomalies of lithium, anomaly means a different one, right? So we'll look at that. At the same time, we'll also look at sodium and potassium, which are very much important in biological aspects. So what is the importance of sodium and potassium in biological aspects also we'll be covering here. At the same time, we'll also see how does group 1 elements, these compounds are important and they are synthesized. We will be covering in the group 1. So, coming to the group 2 elements. Group 2 elements is the group, like the column next to the group 1, which starts with beryllium. You can see the periodic table. Please open the if you open the periodic table and see, this is the second column, right, from left. So we'll start with beryllium, then magnesium, then calcium, and so on. So in the group 2 elements, right, so this group 2 elements will also look at the atomic properties, how they are changing from top to bottom, how they are having properties they are having similar properties with the other group elements, also we will be seeing, right. So basically this beryllium having some relation with Al and all we will be seeing in this chapter. So we will also see how does beryllium is different, again like this same like lithium, how does beryllium is having a little bit different character than the other elements of the same group. So we will be looking at in this chapter. And the next one is magnesium and calcium. Again these are biological importance elements. So we will also see the biological importance of magnesium and calcium. At the same time we will also see the compounds with magnesium and calcium and their synthesis as well. So this is regarding the S block elements, right. So alright, then we will move on to P block elements. P block elements, we will not be covering the whole P block elements, that's it, but we will be seeing only P block elements 13th group. Right, it starts with what? Right, so it starts with boron, which is called this group is called boron family. It starts with boron, so it is called as a boron family. So it starts with boron, aluminium and all. So we will be seeing this family especially, we will be studying this whole chapter based on the boron family. So how does this boron family is having a properties, again atomic properties, ionization enthalpy, ionization electron affinity, all these things, how they are changing the boron family we will be looking at in this chapter. At the same time the compounds with boron like borax, orthoboric acid, diboron, how do you prepare them? Prepare in the sense synthesize them, how do you synthesize them and their properties, their uses and all we will be seeing in the boron family, right. So the other chapter with the P block elements is P block elements, fourteenth group. So 14th group in the sense it starts with what? Carbon family, right. So since it starts with carbon family, we will see the trends that are followed in the in this group, mainly this carbon family group. At the same time we will also see the allotropies of carbon, especially like allotropy in the sense what? Same chemical formula but different physical having a different physical structure or a physical properties it will have. So what are the allotropies of carbon and all we will be covering in this chapter in the carbon family. At the same time we will also see after carbon what is there in the group, next one is silicon. So we will also see, right. So after boron what is there, it will be having Al, after carbon what is having silicon, right. So we will see how does this silicon is having a different compounds, right. How silicon is having a different compounds and also its uses and all we will be covering in the P block elements carbon family chapter. So the last chapter in the inorganic chemistry part is environmental chemistry. Right. So in the environmental chemistry part what we will be covering is mostly different types of pollutions right? So water pollution, soil pollution, air pollution, how do you what steps can be taken in terms of chemistry aspects to control them, we'll be covering in the environmental chemistry part. At the same time, we'll also give a bit introduction to green chemistry, which is very novel, at the same time which is trending, right? So during like this globalization, right? So globalization of earth, so global warming, so global warming of the earth. During the global warming of the earth, how does this green chemistry, something called green chemistry, will be doing? So during this global warming period, this green chemistry plays a very crucial role, very important role. This is given a very high importance in the, you will learn many things in the future. How does this green chemistry is very much important right now. So we'll give you a brief introduction to this green chemistry, just remember, okay? Right. So these are the topics covered in inorganic chemistry. So what are we covering? Hydrogen and its compounds, S block elements, P block element, that is boron family, P block elements, carbon family. Next one is environmental chemistry. These are the topics covered in the inorganic part. So what are covered in organic chemistry, right? Yes, we'll take a small look at organic chemistry, right? So you had a bit introduction in I think in 10th class you had something called carbon and its compounds. Here we'll look at a bit more detail, like what is organic chemistry, like what are the basic techniques, basic principles, basic principles of organic chemistry, techniques. We'll also see the techniques. We'll also see how to identify the functional groups and all. Identification of functional groups and all. So we'll also look at the nomenclature of organic compounds. At the same time, we'll also see the isomerism in organic compounds and all. And the most another important topic also we'll be covering here, that is hydrocarbons. So in the hydrocarbons part, what we'll be seeing is alkanes, alkynes, and aromatic compounds. Right. So aromatic compounds also, up to aromatic compounds we'll be seeing how to synthesize certain things. We'll also see their properties, mainly this alkane, alkene, alkynes. So we'll also look at their properties, how does the hybridization changes there, and all we'll be covering in the hydrocarbons part. See, this is what we will be covering in organic chemistry part, right? Basic principles, techniques, identification and all. Next we will be covering is hydrocarbons. These are the things that are present in our first year syllabus. So next thing what we will do is, we will take a small introduction, very brief introduction to our first chapter. What is the first chapter? Right. So it is our atomic structure chapter. So we'll take a small introduction to it, and then we'll continue to the we'll continue it in the next coming class. So we'll take a small introduction to the first chapter. What is the first chapter? It is atomic structure, right? Right, very good. So atomic structure, okay. What do you mean by atom? Coming to the atom. Right. So how do you define an atom? When did they define the atom? What is an atom? We'll all look at this. Okay. Before going to that, I'll give you an example. Okay. Take anything, like I'm taking some wooden block. I'm having a wooden block. So I'll keep on cutting it. Right. I'll keep on cutting it down, so that I'll get a smallest part, right? the smallest part. I'll be having like this, right? So this again smallest part, I'm keep on dividing it with the available sharpest knives I am having. So I'm going on cutting it down to get again the smallest particle, smallest one again, right? Again with the till where I can see the particle with my own naked eye, I'll be go on keeping on cutting down. So again I can't do, if I am not able to see, I am not able to cut it down. So I'll use microscope, I'll keep this one under microscope and I go on divide it again. I'll get one more smallest particle, smallest one, maybe that I cannot see also. So if I go on like that, then I reaches a point where I cannot divide that particle anymore. I can't divide it, right? So that particle is called as atom, right? That is what we have learned in the previous classes, right? In the previous classes we have learned that definition of atom, right? So we'll also look at this one. So this word actually derived from atomia, Greek words. So which means that atomia means atomia, two words. So uncuttable or indivisible, right? Indivisible means which cannot be divided further. Further you cannot go on cutting it down. I gave an example, right? So like that you cannot go on cutting it. So atom means indivisible particle. Indivisible particle, you cannot divide furthermore. This is what a definition of atom, right? So when did they find the atom? Do you have any guess? Right. So around 400 BC. BC means before Christ. Okay. So around 400 BC, both Indian and Greek philosophers, philosophers thought that all matter, whatever the matter is existing on earth or whatever we are able to see, that is having something in it, like something is building them like that. So they called the atoms as building blocks. So atoms can also be called as building blocks of every matter. So every matter is made up of something. So as that something is nothing but atoms, right? So this is what the atom and its definition. Okay, fine. Now people started thinking more and more. Okay, atoms are there. So okay, we are building, for example, I will give you an example, right? So if I want to construct a wall, if I want to construct a wall, how do I construct? I'll take the sand, I'll take the brick, I'll take a cement, I'll take water, I'll take iron. But what is the building block? What is the fundamental thing? What is the fundamental to build a wall is brick, right? We say it's a brick. Fundamental thing is brick, right? In the similar fashion, matter is made up of all atoms, which is called as building blocks. In the similar way, how we call bricks, we call atoms. Atoms are the building block, that means the fundamental things, right? To build any matter, we need atoms. Fine. Till then, it's fine. So people or the scientists started thinking more and more. How they are thinking? Okay, brick is a building block, right? So how does the brick is made? Right. So brick is made up of something else. right? In the similar fashion, they are also looking at how does this atom is made up of, what are present inside the atom, they wanted to find out. So they were doing some experiments, they have to explain, right? So if I say something, I have to explain, I have to give the proof. So they started thinking what is present in the atom. They wanted to know, really wanted to know what is present in the atom. So they got to know by the end of 18th century and the beginning of 19th century, they came to know some particles are present in the atom, right? If we by 20th century, we are living in the 20th century. So by 20th century, they came to know many subparticles are present in atom. It's not like only just atom, but it's a combination of many elements, like many particles in it, like electron, proton, neutron, these things they already found at the earlier stage. But now neutrino, antineutrino, mesons and all these things they are finding out, right? So we'll not look at all those things, but in this chapter, in our class, what we'll be seeing is electron, proton. We'll only have a look at electron and proton, though electron, proton, neutron, these three are called as fundamental particles. Fundamental particles, right? So electron, proton, neutron, these are the fundamental particles of an atom, right? So but we'll see only electron and proton. How did they come to know, how did they conclude that there is an electron in an atom or there is a proton in the atom? How did they conclude? How did they observe? What they did the experiment? And all will be discussing in the upcoming class. So till here we will be seeing. So what did we learn here? Atomic structure. What is an atom? We saw the definition of atom. At the same time, we also saw these three are subatomic particles, right? These are the subatomic particles. Right. So subatomic, which means what? Atom has something sub, which means which is having inside. Right. Okay. So atomic particles, these are the subatomic particles. What are they? Electron, proton and neutron. These three are also called fundamental particles. Maybe though there are many other particles like neutrino, antineutrino, all these things, many things are there, many particles are there in an atom, but these three only called as fundamental particles. This is what we have learned till now. So tomorrow we will be seeing how does what experiments they did to prove there is an electron in an atom, there is a proton in an atom, there is a these two only we will be seeing. We will also see what is a neutron, very basic thing, right? Yes, what we discussed in this class today, we had an introduction class. We had the introduction to all the chapters that are present in our first year syllabus. So we had three parts: physical chemistry, inorganic chemistry, organic chemistry. In the physical chemistry part, we have seen almost 7 chapters, right? 7 chapters. And in the inorganic chemistry part, we saw 5 chapters. In organic chemistry part, we have seen 1 chapter. So this is the introduction class. So we started with atomic structure. We had also seen subatomic particles. There are 3 particles in it. So these are the 3 fundamental particles we learned, right? So you just have a look at the book, or you just revise your things like what you have learned in the previous classes, in your previous classes regarding the atomic structure. And tomorrow we will start with the experiments to prove these particles, right? Okay, thank you.